So we start our discussion now. Okay, so we are starting from vectors. Quite okay, I know it's not even necessary for me to define what a vector is. You know everything. We know how to add a vector and everything. Okay, but now the trick part is how to get the angle. Okay, now the first thing which I'm going to talk about is when we're talking about the vector, we know that a vector is a physical quantity which has got both magnitude and direction. Okay, now a vector is represented by symbol arrow on top, or you can say if this is the resultant, I can put it in modulus. Some tutors or some lecturers, if you just represent vector with just arrow, they give it wrong. For example, you have vector A, then they want you to find the magnitude of vector A. You know that the formula is supposed to be the square root of rx, this, oh sorry, the ax ay squared. The moment when you just represent this as this, okay, there's some lecturers who are good and there's some tutors who are good as well, but there are some who are bad, you even know. So they are going to tell you that this is not a vector, this is a scalar quantity, because it has got no direction, unless if you put the arrow on top or you put it in modulus, meaning that is a vector. So whenever you are finding the magnitude of a certain vector, just remember to put, if it's a vector b, you need to put this arrow, or you put it like this. You get my point there, eh? Before we continue, a vector is a physical quantity which has got both magnitude and direction. The first mistake you are making is if they ask you to find the resultant, you don't put the arrow or you don't put it in modulus. That is one mistake. Okay, you just put it as r is equal to this. So from today, stop doing this, do this. Second, what you have to know is whenever you are getting angles from vectors, all angles, they are measured from positive x-axis. If this is my xy plane, this is positive x, this is negative x, this is negative y, this is positive y. Whenever we're talking about vectors, we are measuring the angles from positive x-axis. The angle has to come from this line, okay? And it's supposed to go anti-clockwise and not clockwise. It's supposed to go anti-clockwise until it touches where the vector is. So let's say we have got a vector which is there, and we have been told that the angle here is 20 degrees. Okay, they want us to resolve this vector A into x and y component. But before we do that, we need to remember to say, whenever you are trying to resolve any vector into x component, for example, if this is vector A, it's supposed to be vector A x is going to be vector A cos theta. What of vector AY is going to be what? Those who can remember? Those who can remember. You are trying to resolve a vector into y component. What happens?
Sin theta.
Sin theta. So we have A sin theta. Perfect. Now, this is what you need to know, guys. Very, very important. Now, I'm saying whenever we are trying to get this theta is supposed to be, you are supposed to get it from positive x-axis. Now it's supposed to go in that direction. So if we have got a vector, we are trying to come up with the angle. So we have got 20. We know that from this point here all the way to this point is what? Is 90. Now we want to find the angle which we are going to use to resolve vector A. It's supposed to come from this line until it touches the vector. Meaning, what will be the angle for vector A? Come on, come on, come on, come on. What will be the angle for vector A? 70. So it's going to be 70. The reason why it's 70 is going to be 90 minus 70. Very simple. Now, what if I have got a vector which is here? Then I have got 40 degrees here. This is vector B. To resolve vector B into x and y component, which angle am I going to use? Let's do fast. I want us just to know these basics. Let's do fast. Or what are we going to do?
Subtract 40 from 180.
So it's going to be what?
140.
140. Okay, perfect. So here is the issue now. So after knowing that, we need also to know the terms, which were the terms used in vectors. Sometimes you might be given the xy plane. They give you, this is 0, this is north, this is south, this is east, this is west. If a vector is lying in positive x-axis, sometimes they can say positive x-axis, or they can say toward east, the angle is 0. Toward west or toward negative x-axis, the angle is 180. Toward north or toward positive y-axis, the angle is what? 90. Toward south or negative y? Come on. 270. Perfect. Now from here, guys, what you have to understand is that you are going to come across certain some questions where they're going to tell you that you have got vector A, which has got the angle north of east, north of west. Sometimes they can say south of east or east of south. So what it means here, whenever you come across a question which is telling you to say we have vector A, which has got 20 meters at an angle over 48 degrees, or let me just say 25 degrees north of east, meaning this angle of vector A is near east than north, is near to the last part than the first part, meaning that if this is my xy plane here, this 25 degrees is supposed to be near east than north. So I've got this guy here, meaning that this is going to be near east, so here is going to be my 25 degrees. If they say vector A has got 25 degrees north of west, the angle is near west than north. If they say south of west, the angle is near west than south. East of south, the angle is near south than east. Now, here is the confusion. Let's say they tell you to say you have got vector A. Let's say you have vector A, okay, which is 25 degrees. Let's say it is east of north, meaning the angle is near what? Come on. The angle is near what? Let's do fast. The angle is near what? The angle is near north than east, meaning that this angle is supposed to be here. This is going to be my 25. But now, if I want to resolve this vector A into x and y component, I'm supposed to get the angle from this line all the way until it touches that line, meaning that I'm supposed to say 90 minus 25. Guys, that is very, very important. You need to know that. You can't hear anything. Are you sure you can't hear anything? Okay, so I'm talking about northwest. We're talking about north of east. Now we're talking about what if you have been told that it's northwest? There is no of here in between here. It's just northwest. Meaning the angle is between north and west. So which angle is between north and west? This is 45 degrees. Meaning this is 45, this is 45. But for you to resolve this vector into x and y component, you are supposed to get this angle from this line until it touches the vector. Meaning that it's going to be 90 plus 45. Or you can say 180 minus 45, which is the same thing. Does that make sense? Okay, cool. Another issue is here. Whenever you are dealing with vectors, they are going to tell you to find the magnitude. But a vector can't stand alone without the direction, guys. A vector can't stand alone without direction. Please. So what it means there is that if you have been told to find the magnitude, or even they'll just tell you to say find vector A, or maybe find the resultant, meaning that they want you to find the magnitude, they want you to find the size, which is the magnitude, and the direction. Okay? So for example, we know that when you want to find the angle is theta is given by tan inverse ry divided by rx, or let me just say the y component divided by the x component. Now it is very, very important for you to know where the angle is going to be. Very, very important. Now, how can you know to say this angle of a certain vector has to fall in the first quadrant, second quadrant, third quadrant, or fourth quadrant? Here are the steps. If I'm too fast, you should let me know. Okay, cool. So now, if you discover to say the x component is positive, the y component is positive. If you discover to say the x component is positive, the y component is positive, meaning that you know that this is a positive x, this is negative or positive y, this is negative x, this is negative y. So if you discover to say you add the x components and the y components, and you discover to say the x component is positive, the y component is positive, definitely before you even find the angle, you know to say the angle is supposed to fall in the first quadrant. In the first quadrant, that's where I'm going to find that the y component is positive, the x is what? Positive, meaning that that angle has to fall in this quadrant. Now if the angle falls in the first quadrant, the moment when you plug in the values in this formula, the theta which you are going to find, that is the answer, that is the direction they are looking for. Does that make sense? That is the direction they are looking for. Now let's say the x component is negative, the x component is negative, the y component is still positive, meaning that where do we expect our angle to be? In the second quadrant, yes. So in the second quadrant, what we do is we get the 180 minus the theta which you are going to find here. Now here is a step. When plugging in the values here, for example, if you discover to say that the rx is a negative, maybe 2, then the ry is positive, ignore this negative and plug in only positive in this formula and follow these simple principles which I'm going to tell you here. Don't plug in negative values in this formula, just ignore the negatives. Okay, plug in the positive only, and then if it falls in the second quadrant, you say 180 minus the theta which you have found there. That will be the direction which they are looking for. Now if you discover to say the angle is supposed to be in the second quadrant, and then you just find the theta and leave it there, the answer is wrong. Now if you discover to say the x component the x is negative, the y is negative. Where do we expect our angle to be? Third quadrant. Now, in the third quadrant, what we do is we don't use 270, please. The reason why we don't use 270 because this 270 is in y-axis. Okay? We are only dealing with the terminal angles. The terminal angles, when you hear the word terminal angles, even in math, when you hear to say terminal angles, is the angle between the x-axis and where the terminal is. So for example, if I have my xy plane here, okay, this is my xy plane. So if this is my terminal angle, the angle which they want you to find is this one. Okay, so this is going to be from x-axis all the way to the terminal angle. That's how we find the terminal angles when it comes for trig, and we're going to do all those stuffs. Now here what we do is 180. We're going to say 180 plus the theta if the angle falls in the third quadrant. Don't say 270 minus the theta. No, 180 plus the theta. That is the angle they are looking for. Okay. What if the x is positive, the y is negative? Where do we expect our angle to be? Okay. Fourth quadrant. Now, in the fourth quadrant, what are we supposed to do? Yes. In the fourth quadrant, what are we supposed to do? (360 minus the theta). Guys, this introduction which I've given you, believe me, any question which you are going to come across in terms of finding the angle, the terms, is going to be very simple. Now, let us try to check the questions for vectors which came in your exam. The first question was, here's the first question. They are saying that a ship travels 300 kilometers to the south. Now, let's say that is vector A. I'm going to say vector A is 300 kilometers south. So if they say south, what is the angle? I mentioned about that.
270.
270. Meaning that the angle for this vector is 270 degrees. Let's go to vector B. We are going to say that that other one is vector B, and they are saying that, and then 600 kilometers to west. So 600 kilometers to west. What is the angle? 180. Okay. The question is, at what angle, okay, at what angle west of south should the ship have headed to arrive at the same place in the straight path? What they're trying to tell you is this. You have started the journey from this point. This is the origin. This is your origin. You are going where? You are going toward south. So here is the south. Then from here you go 600. So this is 300 kilometers south. From here now you go 600 kilometers west. Now the question is, at what angle west of south? West of south, meaning the angle is near what?
South.
The angle is supposed to be near south than west. That is what they're trying to tell you. So what it means there is that they're saying that at what angle west of south should the ship have headed to arrive at the same place in a straight path. So they want you to come from here direct to this point. So in short, we are saying that this is vector A, this is vector A, this is vector B. Now, this guy is making 190 here. So they want you to find the angle. Okay? So this is the angle which they want you to find. Here is the angle. They are saying the angle is supposed to be near south than west. Okay? Now, here is the trick part. We know that if I want to find this vector, okay, I need to resolve a and b into x and y component, not so. Then I need to add the x components alone, I need to add the y components alone. Now we know that the angle which we are going to find here is going to be, if this is our xy plane, the angle which we are going to find, or let's first do this. Let's resolve this vector into x and y components. We have a, we are going to have ax. Now, whenever we are talking about 270, we have no cos in 270, so we are going to have only sine. Okay? But you can use calculator, it's okay. You say 300 cos 270. Supposed to give you 0. What are you getting? 0. Then we go to y. To y we are supposed to get negative 300 because it is going toward the south. Confirm. Yeah, we're supposed to get that. Then when it comes for b, now bx is going to give us, since it is going in negative, we are going to have negative 600. Now you can just say 600 cos 180 is going to give you negative 600. Confirm. Then we have by. By is going to be 0. If you do 600 sine 180, we have no sign in x-axis. It's just cos. So it's going to give you 0. Confirm. Yeah. So we have it's going to be what? 0. Now you need to add the x-axis and the y one. So you can say that you want to find the resultant. So ax is going to be this plus this. So our rx is going to be, what is ax? Come on. What is ax is 0, bx is what? Bx is negative 600. We are done with that one. So what is our rx now? What will be our rx? It's going to be negative 600 kilometers. Then the ry is going to be what? We add the ay plus by, negative 300 kilometers. Now, listen very carefully.
So I have a question.
Yes, please.
And on bx.
Bx.
The equation for bx.
Sorry, I can't get what you're trying to say. What was our bx?
Yeah, what was the bx here?
The bx was negative 600. It
600 cos 100 is giving me something.
No, it's 600 cos 180 because it is going toward west, so the angle is 180 degrees.
Oh, thanks. I thought it was 100.
No, it's 180. Now, before you even find the angle, the x is negative, the y is negative. Where do we expect our angle to be? Third quadrant. And I said, in the third quadrant, what do we do after finding the theta here? We have ry over rx. Now I plug in the values. Do I include the negative or I ignore the negative? What did we say?
We ignore the negative.
We ignore the negative. So it's going to be the RY is 300. Then you have 600. So what will be our theta?
26.6.
26. 26.6.
Yes.
26.6. If we round it off, it's going to be 27 also. Now, the angle is in the third quadrant. What did we say about third quadrant? After finding the theta, what happened? What next? If the angle falls in the third quadrant, because we're measuring the angles from positive x-axis until it touches the vector.
It's 180 plus the theta.
180 plus the theta. Now, let me tell you, this angle which we have found here, it is here. This is 27. So we want to find the angle from this line until it touches this line. That's the reason why we are saying 180 plus 27. Okay? So we are going to say what is 180 plus 27?
207.
207. Okay. Now, this 207, guys, this is the angle. This is what we have now here. This is what we have. So we have our angle, which is here. This is west, this is south. So the angle, we know that 27 is somewhere here. Okay? So we are going to say this is from this line all the way to this line. It's going to be 207. But the question is, at what angle west of south? Okay? At what angle west of south should the ship have headed to arrive at the same place in the straight path? What angle are we looking for? We are looking for the angle which is near south than west. Okay? Meaning we are looking for the angle which is supposed to be here. So for me to find this angle, what am I going to do?
Subtract 207 from 270.
What are we going to get? Have you seen the trick part of this question? 63. So the answer here was A. Now, they included 207. They knew to say some of you are going to go for 207. They included 27 degrees. They knew to say some of you are going to go for 27. But the answer is 63. Because we are trying to find the angle which is near south than west and not west than south. So as long as you get this concept, guys, north of west, east of north, the last part, meaning the angle is near the last part than the first part. So they are trying to tell you to say, find the angle which is going to be near south than west. So we are trying to get the angle which is going to be near this than west. So if we get 27, meaning that we have changed the statement, meaning the statement is south of west, but they want west of south. Any question there before we continue? Okay, how we are saying that this 207, but you're okay with the 207 where it has come from? You have just joined now? Okay. The question is saying at what angle west of south, meaning that the angle which they are looking for is near what? Than west, not so. So if you check the 207 which you have, this 207 is here. From this point all the way to this line, that is 207. But the question is asking us to find the angle which is supposed to be near south than west. So is this 207 near south than west? Yes, it's near west, but we're trying to find the angle which is near south. So what we have to do is we know that this line is going to be 270. So we need to say 270 minus 207 for us to find this angle which is going to be here. Sure. Okay. Any question there before we proceed? Do you have questions? Let's be open. Do you have questions? Do you have questions? Okay. So here is another question. It was question what I've forgotten, but it had 7 marks. The question is simple and straightforward. While exploring a cave, a person starts at the entrance and moves the following successive distance. She goes 75 meters north, 100 meters east, 150 meters at an angle of 30 degrees north of west. Now, before we do that, before we even finish, first come up with a free body diagram. A free body diagram for vectors always is what? An xy plane. So here is going to be our xy plane. Okay? The first thing which you have to do, put north, put south, put east, put west. I can also encourage you to put positive x, positive y, positive x here negative what? Negative y. Before you even solve, here negative y, here this. Okay, and you know that east or positive x, the angle is 0. Here the angle is 90, here the angle is 180, here is 270. When you come from here all the way to there is 360. Okay? Now, start one by one. The question is saying, while exploring a cave, a person starts at an entrance. Okay? And move the following successive distance. She goes 75 meters north. So I can encourage you to just say this is going to be your vector A. You say vector A is 75 meters. What is the angle for vector A? It is going toward north. Now here is another issue. Some tutors and some lecturers, I've just forgotten one of the tutor from UNZA. What's the name of that tutor? The moment when you read the question, as long as you're not going to come up with a free body diagram, they are not going to give the same tutor I know. I've just forgotten his name. He's not going to give you 7 marks. Even if you get the answer correct, he's not going to give you 7 marks. Meaning you have not understood the question. He's going to assume to say you are just copying from your friends. Now, it is very important for you to come up with a free body diagram. Like here, we have come up with this. Then you start from here. You are going to say that this is going to be from this point here all the way to there. That is going to be our vector A. You say vector A is going to be 75 meters. Now, to be smart, you can tell them to say, let 75 meters be vector A. Meaning, even the one who is marking, you are telling them to say, oh, this is the free body diagram which we have been given. So we have been told that A is going to represent what? 75 meters. I hope you are getting my point, guys. Okay? Then you also say that let B be equal to the second vector which you have 100 meters. So here we are going to have the angle which is going to be what? 90 degrees. Then you say vector B is going to be 100 meters at an angle is going toward east. You even come up with this. It's going to be here. You say this is vector B. You say it's what? 100 meters. What is the angle for vector B?
0 degrees.
0 degrees. Then we are going to say that we have another one which is vector C, which is 150 meters at an angle of 30 degrees south of east. What does it mean when they say south of east? Come on. South of east. Meaning this state is what? Mono. Come on.
That's written. I thought that's written north of west.
Oh, sorry. It's
The angle is going to be
It's north of west. Yes, yes. Yes, mean sorry. The question is saying 150 meters at an angle of 30 degrees north of west. So the angle is near what?
The west.
Near the west, then. Meaning that this is going to be what? This 30 is here. You can mute your mic. You can mute your mic. Huh. This angle is here. But when I want to resolve this vector, which angle am I going to use? That is very, very important. Am I going to use 30?
No,
Uh-huh.
we're going to use 150, I think.
So we are going to get the angle. Yes, we are going to get the angle from this line all the way until there. So it's going to be 180 minus 30, which is going to be what? 150. So 150 is going to be my angle. Vector D, we are going to say that D is going to say is telling us to say is 300 meters north. Oh, south, sorry. What is the angle?
270.
270. Now, after this, we need just to, they want us to find the displacement now. The final displacement, which is the resultant. Now, have you seen here? They have not mentioned anything about the angle. But the moment when you find the resultant, next is to find the direction. So to create space, I'm going to get rid of this. You need to resolve each vector into x and y component. Then add the x components alone, add the y components alone. Come up with what? The Pythagoras theorem. Simple. So what we are going to do is we are going to start with a. We are going to say that ax is going to be equal to the a cos theta. Ax is going to be equal to what is a? A is 75. Because the angle is 90 degrees. We don't have cos in y-axis. The answer here is 0. You can confirm. I'm done with this. Let's go to ay. I have the a sine theta. It's going to be ay is going to be equal to a is 75. Sine the angle is 90. Sine 90 is 1. So the answer here is supposed to be 75. Confirm.
Yes.
So I'm going to say my ay here is 75. It's simple. Even without calculators, you can find. It's very simple. Then you say now you go to b. Bx is going to be equal to b cos theta. Bx is going to be b is what? 100 cos 0. We have cos is going to be 1. It's positive, so it's going to be 100. Confirm. Cos 0 is 1, so 1 times 100 is 100. So we are going to have bx is going to be equal to 100. Definitely, I'm not expecting to have a sign. It's going to be 0. But for the sake of everything, you can say a sine theta. Ay is going to be equal to what is our a? Our a is 100. Sine the theta is 0. So ay is 100 sine 0 is what? 0. We don't have a sign in x-axis. I'll go to c. I'm going to say cx is going to be c cos theta. Cx is going to be c is 150. 150 cos 150. What is 150 cos 150? Come on. Negative 129.1. I'm going to put here 0.9. Isn't it the same as if I just say 1, okay, 0.9? It's okay. So we have cx is going to be equal to negative 129.9. Let's find d. Oh, sorry, the cy. We have cy is going to be c sine theta. C is 150 sine 150. What are we getting?
75.
75. Let's go to D. We have dx. It's going to be d cos theta. D is 300. 270. We don't have any cos in y-axis, so here we're going to get a 0. You just, okay, if you don't know what I'm trying to tell you here, just plug in the values using the calculator. That's all. So what are we going to have? 0. We are going to have 0, not so? Confirm. Confirm.
Yes.
0. Let's go to dy. Dy is going to be d sine theta. Dy is going to be, what is our d? Our d is 3 zari sine 270. Sine 270 is -1. -1 times 300 is -300. You can punch using calculator and confirm.
Yes.
After resolving each, that is the first thing. After resolving each vector into x and y component, now add the x-axis, the x components alone, the y components alone. That's all. So we want to find the resultant. You can say that the resultant, now the x component is going to be ax plus bx plus cx plus dx. So it's going to be ax is 0, bx is 100, cx is negative 129.9, dx is 0. So what will be our rx?
-29.9.
Negative 29.9. Perfect. We go to the next one. And you need to be very much careful. Just become physics, you are going to discover to say it's going to be very much simple and you are going to finish fast. But you need to be very much careful with the Tuma signs. Just simple signs. They can kill you, please. Okay. So we are going to go now to Ry. Ry is going to be ay, by, cy, cdy. So our ay is 75. Our this was b, not so. Our by is 0. Then we also have 75 again. Then plus negative 300. What are we getting? Negative 150. Are you sure?
Yes.
The question is find the resultant displacement from the cave entrance. Here is a simple issue, guys. Before you even find, okay, let's find now the resultant. I can get rid of those. We no longer need them. I can say that r, I said, the moment you just say r, you have to put the r on top, meaning that is the vector now. The rx squared plus the ry squared. So I'll say this is going to be equal to, what is the rx? The rx is negative 29.9 squared plus negative 150 squared. What is our resultant? $152.9. What was the units for the oasis? We have meters. Out of 7, this is 3 point. What you have done so far, this is 3.5 meter, 3.5 max. A vector can't stand alone without direction. The next thing you have to do is to find the direction. Before you find the direction, know where am I expecting to see this angle. Is it going to be in the first quadrant, second, third, fourth? Check the signs. Rx is positive, is negative, Ry is negative. Where do we expect to find the angle?
Third quadrant.
Third quadrant. In the third quadrant, what did I say? After using this formula, Ry over Rx, plug in the values. Ignore the negatives. So we have 150 divided by 29.9. What answer are you getting? What answer are you getting?
78.726.
Come again?
78.726.
78 point. So the theta is 78.826.
726.
726. Let's just put 3 degrees. Is this the answer? Is this the direction for the resultant?
No.
What did we say? After finding this, what comes next?
Add 180.
We add 180. As long as it's in the third quadrant, you say 180 plus 78 point. 78 point what? 0.73. So what are we going to have?
258.73.
258.73 degrees. Now, this is the direction. So this is what you are going to say. After doing everything, you are going to say that down there you are going to say the resultant is equal to 152.9 meters at an angle of 258.73 degrees. What we have done so far, 7 marks, perfect, we have gotten. So the trick part is you need to know where the angle is going to be, because it's half. The marks for the magnitude and the marks for the direction is the same. 3.5, 3.5. And this kind of question is going to come again. Okay? Now, we have another question here. Yes, please. Yes, please. Go ahead.
You said you were adding a 180, right?
Uh-huh.
I'm not understanding why we're adding the 180 because maybe I didn't understand the question.
Come again with your question.
Okay, there's this thing where if the angle is between 0 degrees to 90,
Mhm.
we're not supposed to add anything, right?
Mhm.
But then there, that's like a 78 point something, and then we're adding a 180. So I don't know if I didn't understand the question properly or.
Did you join? You have joined now, or maybe you were there when I was explaining.
No, I've been there, I've listened, but then maybe I didn't understand the question.
We said if the x component is negative, the y component is negative, the angle is going to be in which quadrant?
Third quadrant.
That 78 mama point 3, the one we found, it was here. It was from this line here all the way to there. That was our 78.73. But according to the vector, we want to get the angle from this line until it touches this line. So what do we do for us to come from this line until we touch the line?
We add 180.
That's the reason why we're adding 180.
I'm still.
You are still confused.
Yes.
How?
How is this going to place in that line? Is it because the x axis is negative and the y axis is negative?
Yes, that's the reason. Yes.
Okay, okay.
Sure. You can mute your mic. Thank you. So we have the last question, which is saying the three vectors A, B, and C are as shown. It was supposed to be as shown in the diagram below. Find the magnitude and direction of vector D, which when added to these three vectors will give a resultant. It will give a zero resultant. This question was in the tutorial sheet, not so? Huh? I saw this question in the tutorial sheet. What they're trying to tell you is if you add vector A plus B plus C plus D, the resultant which you're supposed to get is 0. You get it, eh? Hmm?
Yes.
The resultant is going to be 0. So now they want us to find vector B, or vector D, sorry. So we have A, B, we have been given the angles and everything. Okay? So what do we do now? So here is going to be simple method. We need to resolve each vector into x and y component. That's the first step. Okay? That's the first step. So we add these two vectors. So we have A, which is going to be AX is going to be equal to A cos theta. So AY or AX is going to be A is what? Which one is A? Here is our A. So we have 210. It's not degrees. We have 210 cos the theta. What is the angle for vector A?
108.
So AX is going to be equal to what? Negative 210. Not so. Let's find AY. What will be our AY? AY is going to be A sine theta, so we don't have sine there. We're going to have what? What will be the answer? 0. You can plug in using the calculator. It will be the same. Let's go to B. Bx is going to be equal to B cos theta. So B is 180. Cos what is the angle? 45. What is the answer? What is the answer? 180 cos 45? 127.27. 45 is between 90, so even the AY is going to be the same. Plug in the values. Say 180 sine 45, you're going to get the same value as the x component. Confirm. Exactly. Let's go to D. Oh, to B. C, sorry. C is what is C? What is our C? Our C is 110. What is the angle which we're going to use? The angle has to come from this point all the way until to this line. So it's going to be 60, 270 plus 60, not so. So what is 270 plus 60?
330.
330. 330. So what would be 110 cos 330?
Negative 55.
So you have Cx is going to be negative 35. 55, eh? Let's go to Cy. What will be our Cy? Those having calculators, let's do fast.
Negative 55 again.
Okay, negative what? Negative 55 again?
Yes.
What is our D? Dx is just dx. Dy is just dy. We don't know this. But what is our resultant when we add these? They are saying that which when added to these three vectors will give a 0 resultant. So what are we going to do? 0 resultant. Hey guys, 0 resultant. So the resultant is 0, meaning that we have Rx is going to be equal to R cos theta. Even if you don't know the angle, but since this is 0, what will be everything here? Guys, please. Okay, I don't know the angle. I want to find Rx. I have got 0 because I don't know the angle. Even if I get anything here, but still, this is 0. 0 times anything, I'm going to get what?
0.
0. Meaning that what I'm trying to say here is Rx is 0, Ry is also 0. Then you add them now. So you add now. Now we are going to say that the Rx is going to be Ax plus Bx plus Cx plus Dx. Now our goal is to find the Dx. Okay? Our goal is to find the Dx. Let's plug in the values. We see what we're going to have. So we have 0. Our Ax is negative 210. Our Bx is 0. Sorry. Our Bx is 127.27. Our Cx is negative 55. Dx is Dx. Okay? So find the answer here. What are we going to have, guys? We have 0. What are you getting? What are you getting? What are you getting? We have negative 210 plus 127.27 plus minus 55. I'm getting negative 137.73. Confirm. 137.73 plus dx. I'll shift this to the left hand side, so I'm going to have dx is going to be equal to 137.73. So I can. You have got a question? You have got a question? Or you are trying to punch? So we have the dx as 137.73. Let's find dy using the same method. Mute your mic, mute your mic, mute your mic, mute your mic. Mute your mic, mute your mic. Gladys, mute your mic. Okay. So we have Ry is going to be equal to Ay plus By, Cy, dy. This is 0. Ay is what? Ay is 0. By is 127. 127.27 plus Cy. What is our Cy? Negative 55 dx. Our goal is to find dx. 0 has to be equal to, what will be the answer there? 127.27 minus 55. I'm getting 72.27. Confirm.
Yes.
Plus dy. We shift this guy to the left hand side. We are going to have dy is going to be equal to negative 72.27. So we have negative 72.27. Our goal is to find the result, the magnitude and the direction. But here, just a minute, they are going to tell, have you seen this question? It's just asking to say find the magnitude. Or sometimes they are going to tell you that find the magnitude only, but here they have specified to say and direction. But even if they say find the magnitude only, but you need to find the direction, guys. A vector can't stand alone. So you say d, you put allo, the square root of dx squared plus dy squared. Then you have this. Our dx is 137.73 squared plus negative 72.27. We square it. What will be our d? What will be our d? What will be our d? Come on, come on, come on, come on, come on. What about D? 137.2 or 0.73 squared plus 27. I can ignore the negative. It's okay because it will not affect anything. 72.27. I squared. I get the square root. Confirm. I'm getting 155.54. Confirm, 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 confirm.
Yes, it's correct, sir.
This is 6 marks. What we have done so far is 3. Next, find the direction. But before you find the direction of this vector D, first check the signs. Is it going to fall in the first quadrant? Second? Third? Just like that. So from what we have here, dx is positive, dy is negative. Where do we expect our angle to be? In the what?
Fourth quadrant, I think.
You think? So dy is we ignore the negative this. Then you have 137. We have 7 point what? You can't see the screen. Okay, it's back. We have 137.73. What angle are you finding? You just plug in direct. You just say shift. You punch where there's shift and then turn, open brackets. You say 72.27 divided by 137.73. You close the brackets. I'm getting 27.66. Confirm, confirm, confirm.
27.69.
I'm getting 27.66. Confirm. Can someone turn, open brackets, 72.27 divided by 137.73. Oh yeah. Yeah, 27.686. So which is the same as 9. Thank you. Now guys, is this 27 the direction for B? Oh, for D? Is this the direction they are looking for? What if it falls? We are saying that the x is positive, the y is negative. It falls in the fourth quadrant. If the angle is in the fourth quadrant, what do we do?
minus theta.
360 minus theta. So we say 360 minus we have 27.69. What will be our answer? Come on, come on, come on, come on. What will be our answer?
332.
Point what?
3.
So this is the direction for vector B, for vector D. Rust, when putting your answer, you say the magnitude of vector D is 155.54 meters at an angle of 332.3 degrees. Or you can even include to say from positive x-axis. Then you are done. Believe me, what you have done up so far, if I can give you any question under vectors, you not fail to solve. Very simple and straightforward. Do you have questions?